Hello, I'm back. Okay, so we're going to do a couple of examples here to kind of put together everything we've done. All right, and we've found quadrants, right, for larger angles bigger than 360 and less than 0. We found reference angles for different kinds of angles, and then we use those two to calculate the sine or to figure the sine, the cosine, and the tangent of them. Okay, now at this point, you want to resist the temptation to simply just plunk the numbers into the calculator and get the answer, because otherwise then they're just like magic numbers coming out of a magic box, and you never ever want to see math that way. Okay, and in order to or anything else really, and in any case, in order to understand everything that comes after this in trig, you want to make sure that we understand the concepts behind it. Now, of course, later on, there are points where we'll just punch the numbers on the calculator because we'll be working in something else. But for now, it's super important that you work through the process of understanding how all this works. Okay? All right. So let's say that, so we're going to do, there's kind of 3 problems that we've worked on here. Number 1, finding the quadrant for any angle, right? Outside, locating the quadrant, naming the quadrant that the angle is in for any angle. Number 2, finding the reference angle, right, for that angle. And then number 3, putting the two together and being able to calculate the sine, the cosine, or the tangent for them. Okay? So, theta, let's say that here's our first example. Theta will be, hope you guys can see that, 1035 degrees. Okay? Whale. Cool. So what we're going to do is we're going to divide 1035 by 360. Right? Here it is, 1035. We're going to divide that by 360 to see how many rotations, how many excess rotations that is, right? So according to Mr. Calculator, 1035 divided by 360, that's going to be 2.875. So that's 2.875. That means there's 2 extra rotations, right? So 2 times 360, that's 720. So 1035 minus 720. That's equal to 315 degrees. Okay? So that is kind of the angle in the first rotation, the 0 to 360 rotation, without the extra rotations included in it. Okay? All right, so 315, that's greater than 270, less than 360. So our angle here of 1035, that must have been a Q4 angle. So we named that, we identified that as a Q4 angle. Now, what's the reference angle? Well, since it's 315 degrees, we're going to use our Q4, 360, minus the angle, our Q4, reference angle figurine little formula. So this is going to be 360 minus 315. Oh, that's 45 degrees, right? So the reference angle, so that's the reference angle. So the reference angle that goes with 1035 is an angle of 1035 degrees. Its reference angle would be 45 degrees. Okay? Now, so the third step is going to be find the sine, cosine, and tangent values. Okay? Well, and that's going to be of 1035. So what's the sine of 1030? What's the sine of 1035? What's the cosine of tan 35? And what's the tangent of tan 35? Right? Degrees. Well, we look up what the sine, the cosine, and the tangent for 45 degrees is. Okay? The tangent, or rather for 45 degrees, 45 is up here, right? According to Mr. Unit Circle, the sine of 45 degrees is rad 2 over 2, right? That's the sine of 45. The cosine of 45 is also rad 2 over 2. And the tangent, as it happens, of 45 degrees is equal to 1. Now, so those kind of like absolute values are the same. It's just that because tan 35 is in Q4, the cosine will be positive, the sine will be negative, and the tangent will be negative, right? So we're going to say the sine of tan 35 is going to be negative rad 2 over 2. The cosine is positive rad 2 over 2. Sorry, bad planning here. And then the tangent of tan 35 is equal to 1. Sorry, negative 1. Okay? So anyway, so what do we do? This is kind of the end problem here, the overarching problem. But first, define the sine and cosine and the tangent of tan 35. First, we found first we reduced it to 1 rotation around. Then we found its reference angle. And then we looked up the sine, the cosine, and the tangent that went with that reference angle, right? And then lastly, we attached the correct positive or negative sign to it according to what quadrant it's in. Okay? So let's see. Let's try another one. How about negative? I'm going to try to squeeze these in all in one spot. Hopefully I can fit it. How about if theta is negative 1290? Okay? So first we discover what quadrant it's in. So that's 1290 negative divided by 360. And that is negative 3.58, and then repeat. So as we can see, that's 3 rotations around, 3 excess rotations around. So we do negative 1290. Now 3 times 360. Okay, we just divided by 360, by the way. Okay, and then, so that's going to be 3 times 360. That's 1080. So we're going to subtract, because we're winding it backwards here, negative 1080, because that's 3 times negative 360. And that gives us negative 210 degrees. Okay? Now, so that's the unwound angle. So where is negative 210 degrees? Well, that's 210 degrees this way, you understand. That's 210 backwards. And you can visualize that that would be negative 180. And so maybe you can see that that's going to be negative, that's going to be 30 degrees there. So this is actually the same position. Oopsie, did I just do, that's not negative 210. Sorry, negative 210 is passed like that. Sorry. That's negative 180 plus another 30 degrees. So maybe you can see that's the same position as 150, right? So that's the same thing as 150 degrees. So that's the same position as 150. Or you could see it this way. Negative 210, that's a Q2 angle, right? Right? And so, and 150 is a 210 angle. So what we do is 180, we're using our Q2 rule. 180 minus the angle gives us the quadrant, right? So 180 minus 150 is equal to 30. And so that reference angle is 30 degrees. Okay? Okay, so that's how it goes. To do this, we have to have a positive angle. So that's the 30-degree angle. So that's equal to 150 degrees right there, right? And then, so therefore that makes that, and I forgot to write it in here, but let's write it in. That makes this a Q2 angle, right? Because it fell into that side, okay? Fell into the Q2 region. So here we have the angle there is, and so the reference angle is 30 degrees, right? Okay, so now down to the third part. So that's the reference angle. Let's label that. All right, that's what we got there. And then what's the sine, the cosine, and the tangent? So what's the sine of, remember, of negative 1290? What's the cosine of negative 1290? And what's the tangent of negative 1290? Well, that's the same thing as, you understand, the sine of 150, the cosine of 150, and the tangent of 150, and it's 30 degrees, and that's 30 degrees, right? So we can see here is the reference angle, but even since 150 is one of our unit circle angles, the sine of 150 is negative rad 3 over 2. So that's the sine of, the cosine is negative rad 3 over 2. So the cosine of negative 1290 is negative rad 3 over 2. If you look up on a unit circle or your charts, that's the cosine that goes with 150. The sine is 1/2. Since the sine of 150 is 1/2, the sine of negative 1290 is 1/2. And then the tangent there is, as it happens, the tangent of 150 is negative rad 3 over 3. And so the tangent of negative 1290 is negative rad 3 over 3. Okay? So that's how that goes. We're going to give you some homework problems in the book. And if we've got any questions, email them to me, or we'll have a video con about this next time. Okay? Now remember, next time we meet, I think it's going to be our last lesson, or next to our last lesson. Okay, bye.